Boys and girls, this is lesson 2.2, the area formula for rectangles. The guiding question for this lesson is, how can having a formula help us find the area of a rectangle? Go ahead and get that written down in your notebook, date it for today, and then come back. So first you want to complete this question, finding the area of a rectangle. Find the perimeter. You may use a ruler or your template. Write an equation to show how you calculated the perimeter. And then number 2 says find the area. So give that a try. When you think you have it done, come on back to the next slide. And here we go. When we measure this, we would see that it's 5 centimeters in length, and 6 centimeters in width. So if I'm going to do the perimeter, I'm going to be going all around the outside. 5 plus 5 plus 6 plus 6 equals 22. So the perimeter is 22 centimeters. And you don't have to write your equation that way. This is an example. You could have used any of the formulas that we know for perimeter to solve that. So I could have said 2 times 5 plus 6. That works as well, right? Or you could have used the third one as well. Totally up to you. Okay, then find the area, and we can see that if I filled in all of the rows and all of the columns, that I would have 30 square centimeters. Let's talk about how we got that, what strategies we could have used for perimeter and area. So what strategy did you use to find the perimeter? You may have said, well, I measured all 4 sides, then added them all together. You may have measured one length and one width and multiplied by 2. You may have measured one length and one width, added those together, multiplied by 2, or length times 2 plus width times 2. Any of those work. And then what strategy did you use for finding the area? You may have measuring with a ruler to determine the rows and columns, then drawing some or all of the unit squares inside of it, and then you could have counted all the squares or the rows and the columns as composite units. So you definitely could do it that way. You also could determine how many rows and columns there would be and multiply those two numbers. You may have had yet another strategy. You can tell me about it when you come to the lesson. So what is the difference between perimeter and area? Write down what you think in your notebook and then see if yours comes close to what I say on the next slide. So perimeter is the length of the boundary of the shape. Remember, staying around the rim. And area is the amount of surface inside the closed boundary. Uh-oh, there's a typo for us. Let's see if we can get that fixed really quickly while you're watching. Okay, got that fixed up. So area is the amount of surface inside the closed boundary. So the area would be inside of that sandbox we have been talking about before, and perimeter is if I'm walking around the edge, right? Okay. So let's use this diagram that we were looking at earlier to answer a few questions. So the first question is, how many unit squares are there in one row? And we can see that I could check that by just counting the squares. 1, 2, 3, 4, 5. So there are 5 there. And how many rows, let's write the 5 there for you. And how many equal rows of squares are there inside the rectangle? There's 1, 2, 3, 4, 5, 6 of those. So how could we write an equation to write the total number of squares in the rectangle? Well, we could add up all of those rows. So 5 plus 5 plus 5 plus 5 plus 5 plus 5, because there were 6 rows of 5. So I've got 6 5s there, right? So that equals 30. Could definitely do that. It's not a very efficient way. So a more efficient way of doing that same work would be I have 6 rows of 5, right? So 5 times 6, because I have 5 6 times, right? And that equals 30. It's a little bit more efficient way of doing that same exact work. So looking at this a little bit more now. So notice the number of squares in one row is the same as the length in unit squares of the rectangle. So if you look along the bottom there, you can see that if I counted the squares, I would have 8 going across. And if I counted centimeters going across, I would also have 8. Then let's notice the number of rows in the rectangle and see that it's the same as the width in unit squares of the rectangle. So you can see there's 5 rows, and if I measure that up the width, I'm going to get to 5 as well. So then let me ask you this. How many unit squares cover the whole surface of the rectangle? If you counted those up, or if you did 8 plus 8 plus 8 plus 8 plus 8, 5 times, right? Because there's 5 rows of those 8s, you'd end up with 40. So what multiplication equation could we use to find out how many square units cover the surface of the rectangle? And you can see down here that I've said, well, we could do 8 times 5, because there's 5 rows of 8, right? And that equals 40. So the 8 is representing the length of the rectangle and the number of square units in one row, and the 5 represents the width of the rectangle, or the number of rows. And what does the product represent? Product, the number when I multiply two numbers together. The answer is the product, right? And that's the number of square units needed to cover the surface of the rectangle. Interesting how that all works together, right? So here's another couple examples of it. See if you can understand where I'm getting these numbers from. Take a look at the one on the left. So you see I numbered those. There's 6 squares inside, and if I counted going across, I'd see that it's 6. And there's 7 rows, so I could say 7 rows of 6. So 7 times 6 equals 42. The one on the right, I number across to 5. There's 2 rows of 5, so 2 times 5 equals 10. So, how can we use all of these examples to state a formula or a rule for finding the area of a rectangle? Write down what you think. I was thinking along the same lines. Well, I hope you get that we could just multiply the length times the width. This multiplication equation can be used to find the area of any rectangle. And here's the abbreviation, what it looks like. Remember we did the perimeter one where we had P equaling the letters that represented the length and the width? Well, now, instead of adding them as we go around, we add them. For this one, we're trying to figure out the surface in the middle. How many of those squares are there? So we could say it can be abbreviated as A equals L times W. A equaling the area, the L standing for the length, and the W standing for the width. So then look at this one down here. I didn't even draw the squares for you. I could, right? but that would take me a lot of time when I can do it even without those squares being drawn in. If I measure that 7 across, and I measure that 3 high, or the width is 3, let's just use the formula. So we know area equals length times width. That's what this is saying. Now let's fill that in. So the area is equaling the length, which is 7, times 3, the width. So the area is equal to 21 square inches. Just by using my formula and looking at that diagram, I'm done. None of the drawing is required. Hope that makes sense to you. If it does, you're moving on to complete page 37 in your math journal. If you're still a little bit lost, try and watch a little bit of that again, but know that you're going to come to a lesson with me and I'll go over it. So just give page 37 in your math journal a try.